Hi, and welcome to College Algebra 5.2, logarithmic functions and their graphs. So remember that logarithmic functions can also be expressed as exponential using back and forth, this idea that whatever the log base number is our base number. Whatever is inside the logarithm is isolated, and whatever is isolated here becomes the exponent. The way I've always thought about this is sort of like a spiral pattern. I start here and I loop my way out, so I get b to the y as x. Now remember that natural log and e is just the same process, where e is implied to be this base number, so I can still spiral it there. So if I'm going to do that, I can spiral this. I can rewrite y equals log base 2 of 32 as 2 to the power of y equals 32. Same idea, I can spiral this. So log base 5 of 125 equals 3. If you ever see just like log of x where there's no number written, it's implied to be a 10. And whenever you see natural log, it's e is the base number. So on our calculator, those easy ones can be found as logs right there, where you can't change the index number, and natural logs right there. In order to change the log number, you go to math, down to a for log base. So math a is our log base button. Okay. Some common properties of logs that come up. Any log of 1 is always 0, because anything to the power of 0 equals 1 when I spiral it. Whenever these numbers match, they effectively cancel, and whatever the exponent is whatever this thing equals. Same idea here, these effectively cancel, so my exponent is equal to that. And if I ever get two logs that have the same base number and they're equivalent, the insides have to also be equal, which should feel pretty natural. So looking at graphs, remember and recall from, oh goodness, 2 units ago, that that logarithms are inverses of the exponential. So if I take a quick aside, when we did exponentials, they looked, for the most part, like this graph. By definition of inverse, well, that's a bad one. Inverses are reflections across the y equals x. I just need to redo the whole graph, I think. Ugh. Okay. Inverses are reflections across the y equals x line. So the inverse of this graph would look like this. So if this graph in red is our exponentials, this graph in purple has to be our logarithms. So if we look back at our picture, that's functionally what we get here. Instead of having a horizontal asymptote from yesterday, we now have a vertical asymptote. And also, by definition of inverses, the domains and ranges swap. So now my domain is 0 to infinity, and my range is all real numbers. If you remember our exponentials had a domain of all real numbers, and the range was 0 to infinity. So those are just effectively swapped. So domain, as we just discussed, that is 0 to infinity. My range is all real numbers. My intercepts, from yesterday, we had no x-intercepts in the past. This time we have no y-intercepts because I never quite get to x equals 0. In the last one, we had a y-intercept of 0, 1. Here we have the x-intercept of 1, 0. Because, again, the domain and ranges are flip-flopped, so the x's and y's swap. Increasing and decreasing, where those are just about x values. And here we are actually always increasing. But I can't put negative infinity to positive infinity because I don't have all those x values. So my domain is just 0 to infinity because those are the only x values I have. Therefore, that's the only time it's actually increasing. Decreasing, I am never decreasing. Horizontal asymptotes, I don't have one. Vertical asymptotes, as we said, is now x equals 0. Here, we would see that the domain is now negative infinity to 0 because I'm before that horizontal or that vertical asymptote. The range stays the same. My intercept is now negative 1, 0 because I get that reflection. I am now decreasing from negative infinity to 0. I am never increasing. And I have the same vertical asymptote. Okay. Well, just like yesterday, let's talk about transformations a little bit. So again, remember that whenever it's transformations on the inside, it is horizontal, which affect the x values. Whenever it is on the outside, it is vertical, and those affect the y values. Now, yesterday we talked about it being inside of the exponent, because that'd be inside in that sort of structure. Today, inside of the logarithm is what we're looking at. So here, this is inside the logarithm, because it's grouped inside that parentheses. So minus 2, I would go 2 to the right. And we will use, again, our frame of reference of the coordinate 1, 0. So if I move 2 to the right, 1, 0 becomes 3, 0. And just like yesterday, my asymptote yesterday was y equals 0. It's horizontal. And that only mattered and changed when I moved vertically because it changed the y value. Same concept here. My current asymptote is x equals 0. But I'm affecting the x value. I'm sliding everything 2 to the right. So my asymptote is no longer x equals 0. It becomes x equals 2. My vertical asymptote. Everything else structurally remains the same. Another thing to look out for is when you actually graph these on the calculator. Let's see, log of x. It will look like it stops. That is a calculator issue. I promise you the graph goes forever. It just runs out of pixels and it creates a situation where the vertical line test doesn't pass, but I promise it keeps going. Okay. Next one, we have minus 2 on the outside, so that's going to shift everything down 2. So instead of having the coordinate 1, 0, we are now going to have the coordinate 1, negative 2. But my asymptote stays the same, and my overall structure stays the same. Over here, we have an outside reflection, so this is going to be a reflect across the x-axis. So 1, 0 gets reflected across the x-axis. Well, 1, 0 is on the x-axis, so it's actually going to stay there. It's kind of nice. My asymptote also stays. But instead of it increasing and opening up, it's now going to decrease and head its way down. On to the next one. Okay, logarithms. E is used with natural log, but just like yesterday, it effectively does the same things. Okay. Yeah, often when you're doing applications or story problems, you're given some sort of log of x, plus 1, and it says solve when x equals something like that. So story problems are pretty straightforward. They typically give you an equation. When we get to section 5, we'll start writing our equations based on information, but for now, you will be given an equation. Thank you for listening, and I hope you have a wonderful day.